we start working on it together? Or?
So, yeah, the Z-score is 1.96 second.
That sounds right. Sounds right. Alright, do you need a few more minutes working individually, or should we do it together? More, you need more time, Ellie?
Yeah.
Okay. Lisa, do you have a textbook, or if you don't have a textbook, you could look up there. And I would just work on working out the formula, like don't actually do the calculations, just like write out the steps that you would take.
Okay.
Alright, well let's do it. So what is our goal here? What are we trying to accomplish with this problem?
To get the 95% confidence
Yeah, 95% confidence of what?
Of the average time spent online.
Yeah, average time spent online for the whole population. So our goal, I would say, is, maybe we can do that later. So our goal is to try to find the average time spent online for the whole population of these teenagers. So from age 12 to 14, what's the average time that they spend online? Alright, we can't ask every single teenager. Alright, it's hard to imagine asking every single teenager. So we take a sample. Alright, what's our sample size?
754,
Okay, and what do we get for our sample mean?
8.2.
Alright, so that's our point estimate of how much time we might think these teenagers spent online. Alright, but we don't want just a point estimate, we want a range. And we want to be 95% confident that that range includes the real mean, the real amount of time that teenagers spend online on average. So, we know the population standard deviation is 2.6. If we want a 95% confidence interval, what's our z value? How many standard deviations above and below the population mean do we need to go?
1.96.
Yeah, 1.96, excellent. Alright, and what is our standard deviation metric that we're going to use? So what's our standard deviation of the sampling distribution and the sample mean?
22.6 over the square root of the total number, 1054.
Excellent. Alright, and someone who feels comfortable with the calculator can tell us what that is. If you don't feel comfortable with the calculator, just make sure you have the intuition. What's the answer we get to that?
0.954.
Okay. Anyone agree or disagree with that?
It's a 0.09, sorry.
Okay.
Yeah.
0.09554?
Yeah.
Okay. Alright, so that is our standard deviation. So we need to go plus or minus 1.96 of those. So our confidence interval is going to be 8.2 plus or minus 1.96 times 0.0954. And that's it, right? All we need to do now is just crunch that out. And we'll have a confidence interval, a 95% confidence interval. So, did anyone get that far?
Well, that number is not correct,
I have a
I got
different.
8.01 to 8.3.
Wait, which number's not correct? Who said the number's not correct?
I got a different number
but I
for
got
that.
8.39.
The other one, the standard deviation.
Oh, for this?
Yeah.
For this?
Yeah,
What'd you
yeah,
get, Rebecca? 8 point, what'd you get, Francisco?
Yeah, 0.946.
0.946.
4, 6, yeah.
0.946. Maybe did you forget to divide by the square root, Rebecca?
Not a zero, just 0.9.
Yeah, I messed up.
Okay. Alright, so, alright, so we like this, 0.948 for our standard deviation metric. Okay, so we're happy with that correction. So now all we need is 8.2 plus or minus 1.96 times 0.948.
I got 8.01 to 8.39. Is that correct?
8.39?
Around that, yeah?
Okay. I could be okay with that. What do you think, Rebecca?
6 times 0.948.
Yeah, I'm more inclined to believe 10, because Andy,
Oh,
this
yeah,
is
yeah.
one, this is
Okay.
1.96 times almost 1.
Okay.
So that's close to 2.
Yeah, 1.85.
Yeah.
And then how do you get the plus minus?
That's the equation.
You add it and then you
Which minus
subtract.
1.96.
So I get it. You mean, then you
Either
add,
higher or
add that or
lower.
you minus it and that's what the
Right.
variation is?
Yeah, the confidence interval, yeah.
Okay.
Alright.
Oh, jeez.
First smile all.
I know, I'm getting so pissed off.
Alright. So what did, Rebecca, what did you get for this?
10.05.
10.05, what did you get for the low?
Minus 8. Equals
So like,
minus 6.34?
6.34.
Oh, not minus.
alright, I feel like that's wrong, but,
You
Yeah.
gotta subtract the,
does anyone have that,
So
the
1.96
answer in the back of the book?
times 0.948 equals
Is this
minus
right? Let's give someone check
No, I
this.
think, I
1.2
feel like
equals.
my first answer was correct.
Yeah, that's what I feel like too.
0.0946.
Mhm.
I don't know.
So I would
Okay.
subtract.
It's
0.09.
Minus 1.2.
I'm an auctioneer up here.
No, it's not 0.0946, is it? It's 0.946.
Alright, alright.
Do you
We're gonna
need, you wanna
final
borrow my
answer.
calculator?
You're gonna,
Can you just let me get the
2.6
row
divided by,
after you get the?
you take the z-score times the standard deviation and subtract it.
yes.
So 8.2 minus 1.96 times whatever we decide this to be. And we're still working out what we decide this to be.
Square root.
Alright, so do we have a confident answer on this? Susie, you're comfortable with this? The answer to be what, Susie?
I come up with 0.9469, so 0.947, I think.
Okay, fine. Fine. So this is the answer. Yeah? Is that in the back of the book? Says that's the answer?
That's right.
Can anyone look in the back of the book? See if that's right?
Why don't you just tell us how to do it on the calculator? I'll just feel better that way. 2.6 over the square root of 540, 54. How did you punch it in? Just tell me.
So I would punch in, my calculator would probably be different than yours, so I would punch in 574 square root.
754.
754 square root.
754 square root,
Hold on. Wait a minute.
27.45.
Alright, so write that down.
Okay, sure. 27.45, go ahead,
And then clear it.
Clear.
2.6
2.6
divided by that number.
divided by 27.45.
Point zero nine.
0.0947.
Oh.
Okay, I like
It
that.
comes out to the same numbers and.
Point zero
Let's all get on the
nine
same-
The same decimal
four
point
seven.
too.
Yes,
Point 0.947.
Seven.
Okay,
there you go.
I like that better. Point 0.947.
It comes out to the same answer.
No, it doesn't. It comes out to
Right, yes.
an extremely different number.
Yes.
So then you times that by 1.96
Yes.
equals
Yeah, what do you get?
0.1856.
0.186.
56.
We'll say 0.186.
Go ahead.
Okay.
And then you add it and you subtract it from 8.2.
Yes. So
So
take
let's-
8.2 minus 1.
Oh.
8.2 minus 0.186.
Okay. Professor, can you switch a little? 8.2 minus
That's what I had first.
You're getting it.
186 equals 8.014.
8.014.
One.
All right. And what do you get for your high?
Your high would be 8.2. 8.2 plus 0.186 equals 8.386.
Okay. All right. And Francisco, that matches the back of the book, right?
Sure.
No. Oh, okay. All right. All right. That looks like what I got when I did this in class Monday and Tuesday night.
Yeah, that's right, yeah, that's right, yeah.
Okay. Okay? Good, so can someone interpret that answer for us? As you give that interval to your boss, what do you say?
I am 95.5% confident that the standard deviation, am I wrong with terminology?
The average time,
The true
average time.
average time, yes.
True average time spent
Of
online.
teenagers between the ages of 12 and whatever
Yes. Is
is
between,
between
8 hours.
8.014 hours and 8.386 hours.
Yes.
all is well. All right. I am
Peace on earth.
it is 95, Lisa, not 95.5. I'm 95% confident that the true average time spent online for teenagers aged yada yada is between 8.041 hours and 8.386 hours.
Got it.
All right. I think I wanted to do another example, if we're ready. I think we've invested some time in this. Why not make sure we grant? Let's do number 22.
All right, let's just fix it. 22. Each one in our the average salary for teachers and public schools.
Oh, yeah, that's it. It's gonna be. Let's see. You're gonna have to, you might need to zoom in on it. So,
Students in the country.
put on with that,
Based on the same.
95% confidence. We said there's 2.5% chance. So we need to separate the upper 2.5% from the bottom 97.5. So we look for
200
0.975.
teachers.
Right? Highlight it for me.
Okay.
Yeah, there it is. Okay. So that's 1.96.
6583. Salary. Standard deviation. Is 68,000. 6,800.
Sorry, excuse.
6,800, okay. When they use a terminology, average salary, how did you know that 60 was this? How do you know like each one of these?
Oh, because they said so they adopted in a recent study.
Oh, average. And
Average
that's the,
salary.
That's the mean.
Yeah,
So that's what it's, okay, got it.
yeah, and then they say in a recent study
200 is the sample.
it was, the average study was based on 200, yeah,
Okay, got it.
exactly.
And now we just plug it in. We rock and roll. Okay. Here we go. I like that one again.
How you feeling, Susie?
No, I feel all right, my computer is
Oh,
freaking out, so. What's going on with the computer? So-
Plus minus Z. Z. Now, is a Z always gonna be 1.96?
Depends on the confidence level. Why did we choose in 1.96 Z score?
Z, oh,
I don't
Z
know,
score.
that's what I'm confused.
So we said, yeah, if we want a 95% confidence interval, we need a Z score of 1.96.
Yeah. It's the same thing, it's the same
What-
one.
Lisa, what if we wanted a 68.3%
No,
confidence
I'm
interval?
talking about the 99%.
We have a Z score of what? Help us out, Charlene.
68.3?
Yes.
I gotta go refer to my notes, sorry. Okay.
And what if we wanted 95.5% confidence?
95.5, that's where I get 95.5 from, I heard that number.
Exactly.
It's gonna be
What's our
fun.
Z in that case?
Was our Z in that case?
Yeah.
We don't have it that far. Right?
4.5?
2, because 95.5 is within, it captures 2 2%, 2 standard deviations captures 95.5% of the data. So those were just the easy ones. Like if we want a 68.3, z-score of 1, 95.5, z-score of 2. If we want anything else, we have to look on the table.
Okay.
I see what's happening, don't worry. It's like you kind of get it and then you forget because it's confusing. This happens every time everyone learns it. Do not be alarmed. It's like you're kind of like, you get pieces of it and then you lose it all of a sudden.
All right. I'm gonna believe you. I'm gonna believe you, Professor Williams.
But let's do the 1.96. All right, if you want to be 95% confident, what are your chances of getting it wrong?
2 and 2 on the sides?
Yeah, that's right. But if you're 95% confident, you have a 5% chance of getting it wrong.
Right.
Okay. So in 5% chance, you could get it wrong high.
2.5 and 2.5.
2.5.
Of not being in the bell curve.
Yes, yes.
Okay.
So, all right. So you want 2.5, 2.5 here, 2.5 here. So you want to look on your z-score on the positive side for the z that separates the upper 2.5% from the bottom 97.5.
Okay. And how do you do that?
You look on the middle of the z table for 0.975.
Isn't it 0.9938?
Okay, and that's where you get the 1.96. All right, sorry, it's just taking me a little
That's
longer,
okay.
it's late, and it's just
No problem at
complicated.
all. Okay. Question, Charlie?
No, so you would, there's 14.1.
Yeah, true.
That's the sample size.
All right. I hope during that interlude,
Oh, yeah.
everyone has calculated the answer. So what is our goal in this question?
Is to find out teacher's salary, how many people.
Yeah,
what the-
teacher's salary.
The teacher's salary, what the average
Yeah.
mean in the country is.
Yeah, the average mean, the whole population.
Right.
Right, that's what our goal here. We want to find the average mean in the whole country. What do we do in our quest to determine that? We take a sample.
Oh, get it.
And what do we come up with our sample mean?
Our sample mean,
60,583.
yes.
Alright, that's just an estimate. We want to construct an interval where we're 95% confident. Alright, and what is our z value going to be for 95% confidence?
1.96.
1.96. Excellent. So, we are given the population standard deviation, 6,800. What is the standard deviation that we need, though? Somebody say it. What's this? I'll write it, you say it. What is this symbol?
Standard deviation of the sample mean.
Close. Can anyone give me a more precise wording on this?
Sample standard deviation of the sample mean.
It's the standard deviation. You can actually read it. Standard deviation of the sampling distribution of the sample mean.
Sampling distribution of the sample mean.
Yep. Standard deviation sampling distribution is calculated with this population mean, 6,800, divided by the square root of the sample size, 200, which equals what? Lay it on me, Andy.
480.8.
480.8. Is that you, Lisa?
Yes,
Good job. Alright.
and then you times that by
Is it okay
the
if you run it out?
1.96, right?
Actually, really, just leave it in your calculator. Don't round it until you get the final answer.
So then you times that by the 1.96, right?
Yes.
And you get 942.42.
Yes. Alright, so plus or minus 1.96 times 480.8. What did you get for this, Lisa, when you multiply this together?
942.42.
942.42, okay? So you're gonna take 60,583 plus or minus 942.42. That's your confidence interval. And what's
The
that
high
coming?
is 61,525. The low would be
59,640.
59,641 or whatever.
I'll run that off.
Okay. Yes. And what do we say to our boss when we present this interval to her or him?
I'm 95% confident that the standard deviation of the average mean, go ahead, do it.
Yeah, go ahead.
No, you do it.
Go ahead, Francisco.
I was just gonna say, I'm 95% confident that the true salary features around the country is between 59,641 and 60.
Okay, the only thing I would change about that, you're 95% confident that the true population mean
True population mean.
for average teacher salary,
For
teacher salary. So we're trying to determine the average teacher salary in the whole country. And you started off with that question, that's what we're trying to confuse. But once you did all those calculations, you forgot, and that's understandable.
That's 2 hours and 20 minutes later. You got it.
All right, so what if we wanted a 99% confidence interval? What would change about this problem?
The 1 point-
Z-score.
Yeah.
What would it be instead?
2.33.
2.33.
You have 3.33? 2.33? Alright, let's figure it out.
Let's figure it out. Yeah.
Let's figure it out. So we want a 99% confidence interval. So let me draw a Bell distribution.
Chances of
If we're
getting
99% confident, what's our chance of getting it wrong, Julio?
0.5 and 0.5.
Yeah, 1% chance of getting it wrong, as Julio pointed out. 0.5% chance here. 0.5% chance here. And we could say 0.5%, or we could also say 0.005. Does everyone understand those two are the same thing? Alright, 0.005. So we need this z, the one that separates the upper 0.5% from the bottom 99.5%. So if we're looking on the table that I gave you last time,
Yeah.
you would look for 0.995.
49 and 51, there's no 5.
How much are there?
I said there's no 0.995 there, it's between 49 and
Yeah, there is.
51.
Okay, that's fine.
Same table?
That's fine. You can choose either one, or you can average the two. Whatever you prefer.
2.58.
Just 2.5.
2.575.
2.575, 2.58, those would all be fine. So that's your Z for 99% confidence. You need a wider confidence interval to only have a 1% chance of getting it wrong. Alright, how you feeling, Lisa?
How do you feeling?
Alright. So,
We have some tables.
okay, let's get back to the slides. I want to mention one thing, margin of error versus standard error. So when we're calculating our confidence interval, alright, ready to move on? Alright, when we're calculating our confidence interval, we do the sample mean plus or minus all this junk. Alright, it encompasses the z, and this is the standard deviation of the sampling distribution of the sample mean. You'll hear me say that several times throughout the quarter. This, everything put together, is what we call the margin of error. And I think actually Lisa calculated this for us. She said the z-score times the standard deviation of the sampling distribution of the sample mean She said that's some amount that we plus or minus. And we'll call that the standard, or excuse me, we'll call that the margin of error. This, just this part here, the standard deviation of the sampling distribution of the sample mean, a lot of words, and I encourage you to use them, especially as you're getting used to it and just trying to intuitively understand what that means, and I'll try to use it as frequently as possible. But if you get tired of saying all those words, you can instead say standard error. This will
Standard
become,
error instead of saying sampling distribution of the sample mean?
instead of saying the standard deviation of the sampling distribution of the sample mean.
Jinx.
Right.
This will become useful because we'll do other stuff like this. We'll do the standard deviation of the sampling distribution of the sample proportion difference. We'll do the standard deviation of the sampling distribution of the sample mean difference. We'll do some different things and you can call them all standard error. Alright, so that's the definition of margin of error. Okay. Last little section here. We're making some assumptions in this last problem that are not realistic in the real world. Remember, we were given the standard deviation of average teacher salary, or average standard deviation of teacher salary, being 6,800, we were just given that. Did you think that was a little weird? Somebody just gave us that?
Yeah.
Yeah, I really did.
No, it was a
It's a little odd. How would we know
I
that?
had to pause.
Yeah. How would we know that if we don't know anything else about this? Alright, so the thing is, in the real world, we will not know that. So we will need to make a couple of adjustments. One, we'll need to calculate it ourselves. Do you remember when we talked about standard deviation? This was population standard deviation. Do you remember what this was?
Sample fib.
Sample standard deviation. Alright, and this was a little bit bigger. We did a, divided by n minus 1. It's fine if you don't remember that, but this sample standard deviation, we just made it a little bit bigger to account for the fact that we had less information. So when we make it a little bit bigger, this confidence interval is going to get a little wider. So for the same level of confidence, we can still look at our boss and say, I'm 95% confident of this, that it contains the true population mean, it just needs to be a little bit wider. So because of the unknown factors, we will calculate this ourselves, and we will make this a little bit wider. That's one thing we'll do. The second thing we'll do is we'll use a different distribution. We won't use the z distribution, we'll use something called the t distribution, which is also a little bit wider. Alright, so just make sure you intuitively understand the two things we're going to do. One, we're going to use sample standard deviation, which is a little bit bigger. And two, we're going to use a different distribution. So instead of 1.96, we're going to use like 2.03. And we're going to look on the table to determine exactly what it is, but it's just going to be a little bit bigger to account for the unknown factors. So the t distribution, this is the normal distribution we've been using where we get to 1.96. Now we're going to use the shorter, fatter t distribution, where instead of 1.96, it's going to be like 2.04 or something like that. It's just going to be bigger. How much bigger? Well, it depends on our sample size. The t distribution is a family of distributions that has a different z-score, or t-score, excuse me, for your each sample size. If you have a really small sample size, say 5, then you have a really short fat distribution. If you have a larger sample size, say 15, then you have a taller, skinnier distribution. What that means is for the smaller sample size, you need a wider confidence interval because you have less that you know. The bigger the sample size, the more precise you can make your confidence interval. The t distribution uses something, instead of calling it sample size, they call it degrees of freedom. There's a mathematical definition for that. I don't want to go into it. I just want you to know that degrees of freedom is the sample size minus 1.
Okay.
Degrees of freedom, sample size minus 1.
Got it. So now it's got it.
And I think that's on the next page.
Yep.
N minus 1. N minus 1 represents independent terms. and this is called degrees of freedom.
We're coming to the end, thank
Alright,
God.
so that's gonna bring us back to something that should be very familiar. This formula, it should look familiar, right? It's just with a few little differences. Alright, we have the t here instead of the z, and we already know the t is just gonna be a little bit wider to account for the unknown factors. And we have the s here instead of the population standard deviation. And that's also gonna be a little bit wider to account for unknown factors. But the process is exactly the same. Sample mean plus or minus some number of standard deviations, and this is our standard deviation of our sampling distribution on the sample mean. AKA standard error. Okay.
You go, girl. You got it.
Alright. So let's read the t distribution first. Let's do that. Let's go to our t distribution and let's read it. So flip in the back of your book. I'll pull it up here so if you don't have the book. If you have the book, just turn to the z distribution and turn over one page.
I'm gonna figure out, I'm cut online. Oh, why not?
Alright, so this is t. Alright, can you see that? Yeah, you can see that, right? Okay, so the t distribution, we've got degrees of freedom here in the left-hand column. Degrees of freedom is sample size minus 1. And this is actually even a little bit easier to read than the t distribution. Because we look on the right tail area in the top row, and the right tail area for a 95% confidence interval are, actually let's keep this one because I already have this up. So suppose we want a 99% confidence interval. Alright, how much area is going to be in the right tail?
0.05.
1/2 of 1%, and 1/2 of 1% in the left tail. So the t distribution just says you go straight to the right tail area, which is 0.005. That is 1/2 of 1%. And suppose you have a sample size of 8. What is your degrees of freedom?
7.
Yep, so 7 with right tail area, your t value would be 3.499. So you'd go plus or minus 3.499 standard deviations from your sample mean. Alright, suppose you want a 95% confidence interval. What is your area in the right tail?
0.25.
Yes, 0.025. Okay, and suppose you have a sample size of 13. What is your degrees of freedom?
12.
12. Alright, so then for a 95% confidence interval, you would, your t value would be 2.179.
Oh, because you got a minus the 1. To go from 13 to 12, right?
Yeah, exactly. Exactly. Alright, now notice these, this is 95% confidence, right here, this 0.025. What's happening to these numbers as we get a bigger and bigger sample size?
They're very small.
Smaller. They're getting smaller. What do you think is going to be at the bottom of this chart? Okay, I'll kill the suspense. 1.96. So if we have a really large sample size, then we can use exactly the same thing we used on the z distribution. Alright, let's do a sample, or let's do page 256, 7.7. cancel that, let's do, is that what it said? Yeah, 256, 7.7, yeah, that's it, right? And you can see that. Alright, so this is another social media example. Let's, instead of having a sample size of 50, we have a sample of 5, and we don't know the population standard deviation. Okay, so we've got these 5 teenagers who are spending time online. One spends 8, one spends 12, one spends 14, one spends 6, one spends 10. Alright, so you need to find the sample mean and the sample standard deviation, and then you need to show the 90% confidence interval for population mean of social media time. So, think about that for a minute while I erase this. Alright, so how do I calculate the sample mean?
You add 75.
Add them all together, divide by 5, okay? Then how do I calculate the sample standard deviation? Do you remember we did that with those 3 employees? One made 3 widgets, one made 5 widgets, one made 7 widgets?
You add the sample minus the, by the mean.
Yep, check it out. Alright, so this is the mean, 10. Alright, and we take the average distance, the difference between 8 and 10 squared, 12 and 10 squared, 14 and 10 squared, 6 and 10 squared, 10 and 10 squared, and we divide by what? N minus 1, right? So it's a slightly smaller number we divide by, which makes it a little bit bigger. So the number is 3.6. Alright, and then here, let me hide this. So, show me the 90% confidence interval for overall campus population mean. So we've got some important information here. Our sample mean is 10 hours. Our sample standard deviation is 3.16. Alright. So let's calculate our standard deviation of the sampling distribution of the sample mean. How do we calculate that? Same way we calculated it last time, pretty much. Go ahead, Rebecca.
Standard deviation, 3.16.
Yes. Divided by?
Divided by the square root of 5.
Yep. Alright. So, we'll crunch that. Actually, don't crunch it, I'll just, I don't know what it is. Someone just go ahead and give us that answer.
2.36.
2.36?
Wait.
No,
I guess
1.1,
that's the square root of 5, hold on. So,
2.2.
get out of the way. You make a better door than a window. I can't see. Yes, you.
I have 1.143. 413. 413. Yeah.
What?
1.413.
Yeah, 1.413, got it. That's what it is.
Alright, perfect.
Confirmed.
Alright, what is our t value then? For a 90% confidence? If there's a 90% confidence, what's the chance of getting it wrong in each tail?
5.
5%. So we look on the t table for 5% in the right tail. We go down for how many degrees of freedom?
4, no. Is it 4? 5 minus 1?
4 degrees of freedom. And I don't want to scroll back to it, but what do you got, Lisa? I mean, excuse me, Susie. Sorry. I know you're Lisa, you're Susie. So Susie is looking for 5% in the right tail, 4 degrees of freedom, and she's gonna get what?
2.132.
Yes. Brilliant. Really. So, we're gonna take the sample mean, plus or minus what Susie gave us for the t-score, times this, we know this to be 1.413, and it's gonna come out between 6.99 hours and 13.01 hours.
Try it later.
Make sense? Alright, now I feel like a bit of a torturer here, but I feel like it's in your best interest to do one more example.
No.
You'll thank me for it later. Yeah, you wanna do, let's do one more, let's do number 34. Actually, never mind, let's not do 34. Let's not do this one, I wanna explain one thing to you about the t-distribution, which will take maybe 4 or 5 minutes, and then we'll go home.
Okay, cool.
Okay, so, the thing about the sample we just used, or the example we just did, what was the sample size in this? 5, alright. And what did we say, how can we ensure that the sampling distribution of the sample mean will be a normal bell curve?
30.
Sample size of 30 or more. Okay, so it has to be sample size of 30 or more to ensure that the sampling distribution of the sample mean is normally distributed. Now there was an exception to that, and I said, well, this will come up at the end of the class. Does anyone remember what the exception was?
If you have like a really small group, right?
If the parent population is normally distributed. So remember we looked at 2 towns, one was normally distributed, one had skewed income levels?
Mm-hmm.
Alright, so for the one for skewed income levels, we definitely need a sample size of 30 or more to ensure that the sampling distribution of the sample mean is normal. But the one that was normally distributed, we're cool. We don't need a sample size of 30. We can have a sample size of less than 30. And you'll note, on this problem, it told you it gave you this assumption. It said assume the population distribution of times is normal. So it told you that you could assume that the standard deviation of the sampling distribution of the sample mean would be normally distributed because the whole population is normal, regardless of the sample size. So if you see this, you know it's okay to make these assumptions even if the sample size is less than 30. So you want to keep that in mind.
So if not, it's gonna be like sporadic or can't be measured?
Yeah, we can't make, yeah. We cannot assume, we need at least a sample size of 30. And I realize this sounds unnecessarily complicated at this point, but it's just, I need to just kind of get it into your head so that once this becomes clearer, we can distinguish these things.
That makes sense.
Okay, alright, makes sense. Thanks. Sorry for making it sound complicated. It makes sense. The bottom line on this is because the population standard deviation was unknown, we needed to do our 2 adjustments. We needed to use the t-distribution, and we needed to use the sample standard deviation, both of which are a little bit bigger. But the reason why we could even do anything to begin with is because we were able to assume that the population distribution is normal. And that allows us to make these assumptions of the sampling distribution of the sample mean. Alright, so I don't see any angry faces,
I
so I feel like
have a question,
I might have explained that semi-well. Yes, Lisa?
off this, just back onto the syllabi. It says we have a quiz, did we have a quiz, was I supposed to take that quiz? I thought I was supposed to take it here, no?
No, you take the quiz on Blackboard, it's, try to get it done before coming to class. It's fine if you didn't take it, just take it sometime this week. And ideally, you would wanna take class 1 quiz and class 2 quiz before you come to class next week.
Okay, so for next week, make sure both quizzes are done for week 1 and 2,
That's ideal.
okay?
You know, it's
And the
okay.
homeworks are, you need to submit them on to Blackboard.
Yes,
And
yes.
if I'm late a week, it doesn't really, that's not a big deal, is it?
Yeah, so for the Excel homework, it's not a big deal if you're late on that.
But just make sure I do the quizzes every single week.
Try to do the quizzes, those are more important, but for these first couple weeks, if you need some extra time, take the extra time.
I have a question. If the homework's wrong, how would you be able to tell?
Good question.
Why is that funny?
No, but I did it, so I'm just like,
Did
there
you
were
grade
like
it?
2 of them, like I have like question marks,
Oh, okay.
so,
Well, okay. So I will tell you, I don't grade those too meticulously. It's
okay.
just like, if you look like you put in a good effort, then I give you 5 out of 5.
Do you want work shown on the homework, or
No.
it's okay?
There's
to
no
just-
way that I can.
Yeah, you can't show work. I guess I could open up your Excel sheet and I could do, there's a function where I could see the formulas that you wrote.
Alright.
I'm not gonna do that 30 times though. I'm just gonna say, it looks like you got it done, so I'm gonna give you a 5 out of 5.
Alright, so I'm gonna submit the quiz, I'm gonna do the quiz this week, and I'm gonna do the quiz for next week before I come. And then
If
try
you-
to get the homework. done.
Yes, if you can, but if you feel like you're gonna fail both quizzes, don't take them. Call me, email me, we'll try to get you up to
We
speed.
all heard that.
Because once you take the quizzes, I can't change your score. But if these first few weeks you need a little extra time before you take the quizzes, fine. We'll try to get you up to speed as quickly as possible, but if you feel like you have no idea on the material, then hold off on taking the quiz.
Okay, one more question.
Yes.
The holidays are coming up, is each class consistent weeks, like 1 through 10, it's like, I'm going the week of Christmas, I'm going the week of New Year's, all that? Or is there any bye week, I know, for the holidays?
Yeah, there is. You got a
What is
syllabus,
it?
right?
Yeah, I do,
Yeah.
but it doesn't say it.
Yeah, it does. It says on the left-hand column, it says the day. And I think, what do we have? When is Christmas? Is it a Wednesday?
No,
I think it's Saturday.
Saturday. It's like a rip-off.
14th to 21st, oh, so we have the week of Christmas off,
Yeah.
okay,
Perfect.
Yes.
okay, great, thank you.
And I'll be here for a while. If we have any questions, I'll be happy to go over them. You all should be very proud of yourselves for the work you did tonight. It's a lot. And I know it, taking a little extra time in the beginning when we redid the sampling distribution, the sample mean, I definitely hope it helped, but that takes its toll. I know, because I know you all got a little more tired towards the end of this class than my Monday and Tuesday section where I didn't go back like that, just because you're here longer, so it takes its toll. So I want to say I'm proud of you, thank you, and let me know if you have any questions, and I'll see you next week.